Hi, I'm Brit. You are about to watch a sample of me teaching. I will be asking questions to the students and they will respond. Sadly, I wasn't able to be in front of the classroom. That's why I'm doing this part now so that you can see me talking, but you can hear me and hear the students. Enjoy. GPE 7 is use coordinates to calculate the perimeter of polygons and then the area of triangles and rectangles. Let's just go over some basic things of what is the perimeter?
Perimeter is the area of...
No, not an area. What is the perimeter?
The distance around.
The distance around. And what is the area? What's the formula for the area of a triangle?
1/2 times the base.
1/2 times the base times the height. And how do the base and the height have to be related? I'm going to put base and height must be perpendicular. Okay. And then how do you find the area of a rectangle?
Base times height.
Well, base times height, when we call it length times by width, that's an L.
Isn't that volume?
Length times by width. If we did length times width times height, that would be volume, but we're only doing length times width. And again, those, in order for it to be a rectangle, those must be perpendicular also. I'm just gonna put perpendicular, but then if perpendicular, then it wouldn't be a rectangle. So I'm just gonna put perpendicular. The other thing that you're going to need, and you're going to use a lot, is the distance formula. And so I'm gonna write down the distance formula, and then I'm gonna write down a more simplified version of it. So the distance formula says that the distance between 2 points on a coordinate plane is the square root of x2 minus x1 squared plus y2 minus y1 squared. It's an awesome formula, but sometimes students, I've noticed, kind of get lost with what in the heck that means. So this is my simplified version of the distance formula. So it is, the distance is the square root of the change in the x's squared plus the change in the y's squared. And let me kind of give you a visual representation of that. Is if I were to be given 2 points on a graph, like this point and that point right there. I know that to go up, I would have like this is the change in the y's, and I'd have to go over, and that's the change in the x's. And notice that this distance right here is really just the hypotenuse of an upside down right triangle. Bless you. It's the hypotenuse of a right triangle. So we're really just using the a squared plus b squared equals c squared. And if your answer says exact, if you're supposed to find the exact answer, if we had to find this and it was an exact one, I can see that the change, what is my change in the y's right here on this picture? 2. So if I needed to find the exact, and then what's my change in the x's? 4. So I would do the square root of 4 squared plus 2 squared. So 4 squared is 16, right? And then 2 squared is 4. And 16 plus 4 is 20. So this is my exact answer. If I actually found the square root of 20 on my calculator, square root of 20, notice I get this crazy decimal thing. Is there any way to get an exact answer when we have to round?
Yeah, no.
No, it would still be rounding.
That's what I meant.
It's
Sorry.
still rounding, right? So this would be not exact. Not exact would be the 4.4721. And even if you went out as far as you possibly could,
There's still more in the calculator.
there's still going to be more. It's just that your calculator has to stop. When it says exact, we do not want decimals. Do we want decimals? No. We do want this. So really the only thing that you need to type in the calculator is this part, this 4 squared plus 2 squared. And because you have a brain and you can use it, you can simply type, like, you can simply draw the square root after.
Wait,
Yep, yep.
Couldn't you just do the first equation because it makes more sense than the other ones?
I don't know which equation you're talking. Does this equation make more sense to you? Then yes, you can. Just make sure that when you're doing this one, if the points that you have are negatives, that you put the negatives in parentheses. Let me show you an example of doing the first one with parentheses. Let's say we had a parallelogram. You're going to find the perimeter of this parallelogram. So we have A, parallelogram A, B, C, D, and A is at 6, 7. B is at 36, 7. C is at 18, negative 8. And D is at negative 12, negative 8. You did this on Alex? Good. Good. So we have this parallelogram, and we are supposed to find the perimeter. Now you could find a huge piece of graph paper and try to graph all these things. I will show you the formal equation way, and then I'll show you my kind of shortcut way. So formal equation way, I want to find the distance from A to B. So from A to B, I'm going to do the square root the change in the y. So how far is it from 7 to 7? Well, so we're going to do 7 minus 7 squared, because those are my y's, plus, parentheses, 36 minus 6, close parentheses, squared. And then you have to close the parentheses again, because you have two of them.
Why is there two of them?
Because one of them is for the change in the y's, and then one of them is for the entire thing. And we actually don't want the square root, because it would, then you'd get a decimal, and if you did put the square root first, then you could square it at the end. Okay, so then 7 minus 7 would be 0 squared, right? And what is 36 minus 6? 30 squared. And technically, we know that we can just put the square root at the end. So 0 squared is just 0, right? And what's 30 squared? Huh? 900. And this is the exact answer.
Wouldn't 30 be the exact answer too?
Square and square root.
Yep, exact. And then because the square root of this is actually a really easy one, it would be 30. Good. Okay. So we found one of the sides. And if this was A, B, this is what I do. I just draw any old parallelogram and I label A, B, C, D. And then I know that this one was 30. Notice I did not draw a fancy graph. I just drew a little tiny picture. Which other one is also going to be 30 long? Yeah, we know that this one right there is 30 long, right? Okay, so now what's a length that we do have to find? Let's do A to D.
And then we find the whole thing.
So I'm going to do this now the way that I do it without doing the lots of parentheses. So from A to D, I look at A and I look at D. How far apart are 7 and negative 8?
15.
They're 15. So I'm going to do 15 squared plus, and then how far apart are 6 and negative 12? 18. Do you guys see that? If you can't do that in your head, don't do it that way. Go back to doing the parentheses. But notice I skipped this whole big step up here, and I just went to right there.
Wow.
And then I can use my calculator. 15 squared plus 18 squared. So I would get the square root of 549, and sometimes it's good just to check the square root of that answer. And it's a crazy decimal, so I know that this is exact. Okay, does that make sense? So this is the square root of 549. Question first?
So when I was doing these on Alex, I figured out, so like for AB, if either the x or the y is the same, you can just find the difference in the x or the y. No,
Yeah. So like she can see like, look, the y's are the same, so you can just ignore that part. And then I can see that from 6 to 36, that's only 30. And then 30 squared is 900, and the square root of that is 30. So really this is the thing. That's what she's saying. Okay, so to find the total perimeter now, we'd have two of them that are 30, right? Because I have the one on the top and the one on the bottom. And then I add on two of them that are the square root of 549. So what is 2 times by 30? So technically, this is the exact answer. This is exact. If you can do a decimal approximation, just type it in your calculator. So 60 plus 2 square roots of 549. And so the decimal approximation would be 106.9 units.